I did not have time to do slides. I was going to do it on the bus ride here, and I had some other stuff to prepare. So last minute, we are just going to do a short run-through and discussion, anything you guys want to ask once I sort of give a short intro here. Part of the reason I'm giving this talk on Track B is JavaScript is such an amazing language that it's so tempting to use it for everything. Now, that's great when you need it, but we should also always consider languages that really fit the problem best. Not even just good, but really, really well. It's always good to have that extra edge. So one reason I chose Lua is because it's almost so close to JavaScript, you would say that we might as well use JavaScript. But I wanted to show a few reasons why that might not be the case. The first one, and kind of the provocative point I was going to show in a demo are some benchmarks versus V8. So if you look at this graph, it's a little cryptic, but if we scroll down here a little bit, we can see some numbers here. PyDigits is a benchmark that generates some numbers. So Pi numbers aren't generally useful in real code, but we can see that Lua is literally 87 times faster, not just 4 or 5. This is the sort of difference that we tend to see in like C versus something else, not Lua.
What JavaScript runtime is this?
This is V8 versus LuaJIT. So also the memory usage and other things, patterns are very impressive. Now if we look at some of these other ones, we see that here at the top, there are a few cases where V8 is faster. I think it's mostly the Tune JIT-based regular expression engine they use, which is really, really fast. I don't think Lua does any JIT compilation for regular expressions at this point. But it's very, very compelling that you can get something so performant in a language that's so dynamic, literally to the point where, let me adjust this comparison. Let's say, check against the Java 6 server. This is in JIT. Very, very, very close. I mean, on PyDigits, it's actually faster. And then on some of these, it's only just a couple times off. And plus or minus on some of these benchmarks might as well be the same. And keep in mind, look at the memory use. That's amazing. It's still very, very lightweight. To accomplish this is really, really impressive. So LuaJIT's an amazing piece of code that this guy Mike Paul put together, and I definitely think it's promising for JavaScript in the future. But right now, if something like embeddability and speed are both really important, you should possibly consider this. Also, for the education of how you write your JavaScript programs, the best way to really get a hold of that better is to actually use other languages, to actually extend the way you understand JavaScript itself. So unfortunately, let's see if I can find some examples in the original book. They have a second edition of this book, Programming in Lua, which is great, but it's not available for free online. But the first edition is. So let me see if I can find the link. Here we are. So Lua generally looks very much like JavaScript. You'll see a couple differences. I guess I have to click on one of these sections. Well, let me go over some of these short sections without clicking on them. You generally have nil, which is like null. You have booleans, numbers. Numbers are the same, single class concept in JavaScript. Strings are very, very similar. Tables are probably the first interesting thing that will vary. Tables in Lua are used for both array types and hash types. Tables are very, very well optimized in Lua, which allows you to basically get array-like performance when you're using it like an array, and then you can get a hash table-like system when you actually use some other key, like AX. And you can also do the access just like JavaScript. A.x does the same thing. A gotcha with Lua, though. Indexing starts at 1, not 0. I'm not going to go into that. Just be aware. It's a subject of much controversy. So if we go through this, a lot of this we'll probably read pretty easily. It's got a slightly nicer to read for loop style here. I much prefer this over the we borrowed it from Java concept in JavaScript with the for and increment and the compare. This tends to be a lot easier to optimize as well. Possibly one reason Lua gets a lot of performance. Let's go to another section. We've got functions, which are obviously important. If it loads. Okay, where's some code? Just need some code. Okay, we're going back to the table of contents. Part 1, the language. Where am I going? Okay. So yeah, here we go. So functions obviously wrap things up just the way it does in JavaScript, although instead of curly brackets, we use end. Let me get that higher for you guys. So generally, you still have the explicit return. You have to declare your local variables, which is still a pain in the ass. It should be automatic, I think, in modern languages, but Lua, like JavaScript, is quite old. So local sum is just like var sum. Notice we don't have any trailing semicolons. They're all optional in Lua. There are fewer problems with the grammar when you leave them off, so it's perfectly fine to not add them in. In this case, we have another form of the for loop. This is a for in. This allows us to get integer pairs, so the actual index and the value. And then here we pass in the actual array that we want to sum. So basically, we're summing this up and returning the value of all the integer elements in this array. So very, very similar in that sense. Now, if we go to some of the more advanced stuff, besides syntax, we start getting into some more interesting things that we don't find in JavaScript. And this is where possibly you can start thinking about how you can change the way you use or even generate JavaScript to do other things. Coroutines are amazingly great tools for certain things. Have you ever wanted in your asynchronous AJAX code to write, OK, send this back and assign it to a variable? I don't want to call back. I just want to assign it to a variable, and then maybe I want to do something with that variable and send it off somewhere else. Well, coroutines let you do that. What it basically ends up being like, let me see if I can get a good example of code. Pardon the web. OK, so here we have a producer and consumer. So you can see that one's just looping. It's not yielding. There's no callback here. It's literally saying send and receive. If you look at both parts, we have send and receive here. So these are basically the callback points between the two coroutines. Now, this send and receive is just abstract code. Internally, you actually have to use coroutine resume and then coroutine create. Now, send right here is basically a synonym for coroutine yield. So we have these two coroutines that are bouncing back and forth, kind of like parallel stacks that allow us to pass values back and forth. So what you could have in a system that wanted asynchronous AJAX requests in JavaScript with the same sort of thing is you would have to emulate coroutines with a compiler and then allow the code to basically yield to the AJAX calling engine. Then when it's done, it would actually resume with the value in the result rather than calling a callback. So resuming versus a callback. Now, coroutines aren't free. They do have a little overhead. They are possible, unlike a lot of rumors, to implement efficiently. So it's not impossible to get these pretty lightweight, but they're still going to be a little heavier than, say, the overhead of a callback. You're looking at probably 4 to 8K per coroutine, possibly up to 1 megabyte if you're using native C stacks to implement them. So there's something you need to use carefully. But but still very powerful. Likewise, you can create very easy to use iterators. One thing that's very popular is to build a simple loop to generate values and then externally treat it as an external iterator and just call next, next, next when you need the value, so you're pulling. And this is very popular with generators in Python, and then also something we see in Ruby 1.9. And of course, it's kind of like a cooperative multi-threading, so I'll skip that. Otherwise, it's got a lot of meta programming capability, and this is probably the next and final. Well, I'll go over one other thing. The meta programming capability in Lua is great. Like people asked Douglas Crockford, when are we getting something like method missing in Ruby to be in JavaScript? And we do have defined property now, but it doesn't allow us the capability to catch arbitrary keys for any object. So with meta tables and meta methods in Lua, it allows us to basically set in a meta table for any other table. A table is kind of like your object. I'll explain that in a minute. And you can define ways that property access, property generation, property setting, all of that works through these meta methods. So table access meta methods, we can look at this. Oh, great, it's not going to show me code again. Let's see. So you can see there's get and set meta table. So S1 is basically our pseudo object, and this is how we control the meta tables on objects. We have things like toString, which helps control how things are coerced to strings when we want to print them out and such. We've also got index and new index. These control generation or missed property accesses, which is really useful. It allows you to basically do method missing and do it very flexibly. So I'm not going to go too much further into that. Again, trying to keep this somewhat short. The next area that's sort of interesting is how Lua does OO programming. It's very similar to JavaScript in a way. It's more prototype-based. So we have these tables that are just bags of properties. Now, the cool thing about these tables is the keys can be anything more than just strings. So we can basically create any sort of mapping between one set of accessor and another. It allows a very rich way to create something that looks like an object, and then you can give it better behavior by adding stuff via the meta tables or basically creating inheritance via the meta table feature. So you can basically say, look things up in this object when you can't find it here. Since this is totally user programmable, though, people have come up with all kinds of ways to program Lua. There are many, many ways to do the meta table setup. So people have emulated class-style inheritance systems. They've emulated purely prototype and differential inheritance-based systems, as well as something more like self, if you're familiar. So the syntax that you should be aware of in this case is this colon right here is somewhat like passing self as an implicit argument to the function itself right here. If we called it without and just did dot, it would expect that first argument to be self. So as we see, we don't have to declare it, and it's available here. Self, just if you guys are wondering, is like this in JavaScript. So we can see we're setting up an account here and basically setting up the meta table, kind of like a constructor. Usually you wouldn't have to implement new unless it's a base class of your OO system. And then account.deposit, you can see how A is actually our account instance, and otherwise if we did colon A colon deposit, it would actually call the meta table. So that's the quick intro, the rough information here. Do you guys have anything you want me to explore or questions?
Is there any script for a function interface for other languages?
Yes, Lua is actually probably one of the easiest languages to work with as far as C goes. So it's not only easy to write actual C extensions and then embed it in other C environments, but there is a huge amount of community out there that has contributed a lot of libraries. One of the things you'll notice, let me show you, I'll scroll down here a little bit, is the standard library is actually very short and small. So we have basically, a little bit of math, some table stuff, string stuff, a few I/O things, and some OS things so you can start and stop and exit your process. The reason it's so minimal is initially it was more so for embedding in other programs that had their own sort of domain to work with. And here we see that we need a lot more to do, say, foreign function interface stuff. So people have provided those, and you can basically require them in dynamically at runtime. And that's been a very big benefit to the Lua community. But unfortunately, batteries are still not included, so you do have to go search those out and install them.
How's debugging when you embed it into web pages? Since this is one.
Oh, it's not available in web browsers. Web browsers haven't implemented it. People have worked on some early Lua to JavaScript compilers. Unfortunately, since Lua is a little more dynamic, it's a little hard to do a very literal translation to JavaScript. So it's more so of a series, VM plus whatever compiler you're using.
Can you speak more to the difficulties that are encountered when porting it, the dynamic aspects?
Yeah, so the meta table allows you to take these objects and basically intercept anything happening with them. In JavaScript, obviously we don't have catch-alls, so that's a big problem.
Strawman proxy.
Also, a thing that I run into very, very quickly all the time in my JavaScript code is when I want to key an object off of something other than a string. You have to generate symbols to act in that place for you. Lua is nice enough to just allow you to use anything you can put in a variable as a key. So that's actually quite nice in Lua, but again, more emulation in those sorts of areas.
Do you see Lua as primarily an alternative to server-side JavaScript? Because Lua won't run, for instance, in a browser.
Right. Well, Lua's actually... Oh, yeah, OK. So as an alternative to server-side JavaScript is actually quite a good point. They do have bindings to libev and stuff, so there are things that are still immature but starting to become comparable to Node in Lua. So that's actually very, very interesting. But the big thing about Lua is it's easy to embed in any projects that you might be developing. So if you have a piece of software that's even, say, a Ruby-based web application, you want to run something other than Ruby in that, you can easily embed Lua in Ruby or Python or a Java program via a lot of different facilities. On the client side, if you do anything with thicker applications, not just pure web, it's definitely a good option. And then on mobile platforms, we're starting to see a lot of platforms actually install it in the core. Android, for example, includes a Lua interpreter to help developers quickly prototype things.
Just on method missing, is that implemented by adding something like a method missing key to an existing object?
It's through the meta table, so that under index and
conflate the namespace.
Right. So it definitely doesn't actually touch the namespace, and there's no like special star attribute or something like that. I think the approach is actually very, very intelligently done. Anything else? Thank you.